morning. We're going to go ahead and talk about chapter 1.1, and I'm going to do some talking over the PowerPoints maybe to make it easier for you to understand. So, what is statistics? Statistics is a science, and that's the science of gathering, describing, and analyzing data. Some people are kind of shocked that it's a science, but while it is considered a math course because we do mathematical equations, it is more a science. Or, not to confuse you further, statistics is the actual numeric description of sample data. And usually it's called sample statistics when we talk about that. So let's talk about the language of statistics. So a variable is a characteristic or a value that changes among members of a group. Variables whose values that are determined by chance are called random variables. And that happens when you choose something and it randomly occurs. Variables can be numeric or categorical. Numeric variables take on values with equal units such as weight in pounds or time in hours. Categorical variables place the person or thing in a category. So when you gather this stuff, we call it data. And it's the counts, measurements, or observations gathered about a specific variable in a group in order to study it. A datum is a single value of data, but we don't really use these in statistics. We usually try to have more than one data value. So let's talk about a population versus a sample. So a population is the particular group we're interested in. It consists of all the persons or things being studied. And examples would be like all American adults, the 5,000 or so students enrolled at GHC during spring 2011 are the governors of the 50 United States. As you can see, some populations are easier to get information on than others. In the US, when we look at the census, we only have a 62 to 65% success rate of people who will actually answer the census. So instead of getting the population sometimes we take a subset called a sample. We have to be really, really careful when we take this sample so that our population is well represented and the results of the study are meaningful. So what we might want to do then is take a study of like 1,000 adults who survey to see how they feel about marijuana. Or we could take 28 students in a class to determine height. So you got to kind of think of it as this thing. Population is the whole group, sample is part of this group. You can have many samples in a population and you try not to let them overlap. But the more samples you take, and if you kind of average the data together, you get a clearer picture of what your population is. So populations have characteristics called parameters, and it's a numeric description of that population's characteristic. It's a fixed number, but it's kind of impossible to determine if it's precise. Where we can look at a statistics, which is the actual numeric description of a sample, and it varies from sample to sample. So we have to be careful and get a representative sample so we can talk about the population. So again, populations versus sample. The population is the whole group, and the sample is part of the group. The population is the group I want to know about. The sample is the group I do know about. Again, characteristics of a population are called parameters. Characteristics of the samples are called statistics. Parameters are generally unknown and they're fixed, where statistics are known and they can change based on the sample. So let's look at these. Determine whether it's a population or a sample. The ACT scores of all students in Miss Ralston's Math 2200 class. There's a key word in there that tells you if it's a sample or population. That word all lets you know it's a population because we're getting everybody in a certain group. The second one is television shows watched by 1,045 families from across the U.S. for Nielsen ratings. Okay, when you think about across the United States and you're thinking of families, we can't even really start to estimate how many different families there are because families are defined as one household, one head of household, two head of household, So if we're only looking at roughly 1,000 of them, we know that we're not getting every type of family or every family across the United States. So this would be a sample. The height of 15 out of 30 plants in a greenhouse. When we look at that, 15 out of 30, we see there's part of the group out of the total group, which is 30. So 15 is part, 30 is all. So that would represent the sample. Here's another one. An education professor wants to know the hometowns of students attending Yale University. She obtains a list of the registered students from the registrar's office and randomly chooses 300 students to survey. Well, when she got the list of all the registered students, she got the population. But when she only chose the 300 students, she chose a sample. So that's the difference about that. A hotel chain wants to build a new facility. The board of directors use a list of the top 100 vacation spots in America and visit 20 of the cities on the list to determine the feasibility of the new hotel location. Again, we have 100 top vacation spots, which would probably be our population, and they only visit 20, which is our sample. So this again is a sample. Okay, so now let's try to identify the values in each statement describing if it's a parameter or a statistic. 35% of all graduating seniors from Kennesaw State University receive a degree in business. So because it's talking about all graduating seniors, this would be a parameter because it's talking about a population. So the average height of a sample of men entering the armed forces is 6.1 feet. Well, we see in there it actually says sample. So that means that's a statistics because we're talking about a sample. The students in Miss Ralston's Math 1111 classes have an average of 2.5 siblings. So if we're talking about all the students in Miss Ralston's Math 1111 classes, that would be a parameter. So there's one more thing that we're going to talk about in this chapter. It's two branches of statistics, descriptive and inferential statistics. Descriptive is, as a science, it's collecting, organizing, summarizing, and presenting the data. You can kind of think of it as just the facts. You could actually have data in tables, graphs, or numeric summaries. So you refer to the sample without making any assumptions about the population. What you see is what you get. So what we do with this type of statistics is we use that descriptive statistics to estimate population parameters. So you're interpreting the data you collected. So if you've got a table, you're kind of describing what you see in the table. If you've got a graph, you're describing what you see in the graph. So you use it with descriptive statistics in a statistical study. Kind of your descriptive statistics is your results, what you show, and then your inferential statistics is how you explain what you have. So let's look at a few examples. 82% of employees from a small local company attended the annual company picnic. Well, that's pretty easy to look at and see that you could count the employees and see that you got 82%. So that's descriptive. Average age of entering freshmen at the University of Georgia is 20.8 years, based on information from the registrar's office. That would be descriptive because they actually got the information. The average number of vacationers spent in national parks during the summer month is 4.5. So that would be a tough one, but I would say it's inferential because you could see where the information came from, but you might not be able to track every person in the national park. So you took a sample and you're estimating. Okay, so that was part of 1.1, and I'm going to stop the video now and we'll keep going with more definitions.